Hi Tens, in this video I'm going to be going through sketching parabolas by completing the square. So we've already had a look at the process of completing the square, but let's have a look at it in the big picture about how we complete the square and use that to sketch a parabola. So in this, we've already looked at factorizing. Well, this is another way, and in particular it's a way of getting these parabolas or these quadratic equations into what we call turning point form. Okay, so turning point form is what we're after. And from there, hopefully, looking at this turning point form graph, we can find the X-intercept slightly differently to how we were doing with previously factorizing. And also label the key features. So we're looking at the turning point and the features of the turning point. So that's what we're going to be looking at today. You can determine the key features of a graph in turning point form. Okay, so we're determining the turning point, the Y-intercept and the X-intercepts, and we do it a little bit differently to factorizing when we're looking at ones what we could factorize. And finally, we can sketch a graph by completing the square first. So over here, now just so you know, completing the square, often if you can factorize, we will also always try to factorize first. Now, sometimes in a question we might ask you to sketch by completing the square, but if you can't factorize, you can complete the square at any time. Okay, so just remember, factorize first if you can, but of course, if you're asked to complete the square, that could be also a bigger hint. If we sort of ask you to complete the square, then you're going to have to complete the square to sketch rather than factorize, because not everything can be factorized. Okay, so for example, in this thing over here, I need two things. If I'm trying to factorize, I need two things that multiply to give 20, and they add to give, so they were just factorizing trinomials here, and they add to give 8. Now, if you think about it, the factors are 20. 1 times 20 is 20. 2 times 10 and 4 times 5. Now, none of these, 1 and 20, are going to add to give 8. Now, 2 and 10, you think might, but you know, 10 take away 2 is 8, but 10 times minus 2 is not 20. Okay, so there are no two pairs of you know, sort of things which actually multiply to give this. So we can't factorize. Okay, so if we can't factorize, we can complete the square. I'm going to go through that whole process with you. All right, so a little bit of theory here, which basically sort of says that we can complete the square of all quadratics. Expressed in this form, it's just sort of ax squared plus bx plus c form. And what we can do is we can express it in this form, what we call turning point form, and we do that by completing the square. It then talks about that we're looking for a turning point in this form here, has a turning point at hk. Very important to see that, hk. So this is what we call, this thing here, this is what we call turning point form, because if I have a graph in this equation, if I have something like this in this form, then it says that the turning point is at h and k. So of course, now the way this can be a little bit confusing at first, because you've got over here at x minus h. But I guess the way to think about this is, what would h have to be? What would x have to be? For the bracket to be equal 0. Okay, so can you see here that I've got x minus h squared? Forget about the squared for the time being. What does this have to be for this to be equal 0? Well, x would have to equal h. Now that happens to be the turning point, the x part of the turning point, and the y part of the turning point is this k part. So it can look a little bit confusing, but for example, over here, let's have a look at an example. Okay, it's probably a bit easier. It says, determine the coordinates of the turning point and state whether it's a minimum or a maximum. So the one more thing you need to realize is that a positive quadratic Okay, so definitely quite a few concepts here. If you're seeing this for the first time, which a lot of you are, you're sketching these for the first time, you need to recognize that there's a few things. First of all, we've got turning point form, then we've got, if I've got a quadratic which is positive, then it's going to have this looking positive. Think about it. If I have a smiley face, positive, it's going to be a positive parabola. If I have a negative out the front, then yes, you guessed it, a negative out the front is going to be a sad quadratic or parabola. And as you can see, that's going to be like a sad face. It's going to be inverted. Now, we actually had, if you're watching this from school, then from Ivanhoe, then you have already done a self-directed parabola task, and hopefully you saw the effect that this negative has. You can see that this negative is going to have an effect. Actually, what we're going to do in terms of the maths jargon, it's basically reflected. This is reflected in the x-axis. It's reflected in the x-axis. Treat the x-axis like a mirror, and it's reflected. That's what this negative is going to do. Now it says here, determine the coordinates of the turning point and state whether it's a minimum or a maximum. Well, first of all, if we have a look at this point, just look at the negative. Can you see here that this negative is going to mean that it's going to be turned around this way, which means it's going to be, what is that? That point there where it turns, is that a minimum or a maximum? Well, hopefully you can see that the highest point is that turning point, which will, so this is going to be a maximum. Now, let's have a look at what the coordinates are. Well, first of all, I'm going to rewrite the turning point form for a quadratic. We'll sketch it on the CAS as well in a second. So we've got that. Okay, now what we've got is we've got a turning point is at what we call HK, where the turning point form, we've got here AX minus H all squared plus K. Can you see here that X minus H squared? Well, you see there that in this example, that H is equal to 1. Or what would this have to be for this bracket to be 0? X would have to equal 1, basically. And K is our constant here, which is 16. So that means that we have a turning point at 1 and 16. Now, later on, we're also going to see that, like if I go and sketch this now in the CAS, and I put this all with a -4 at the front, the -4 doesn't affect the turning point, but what it does do is it affects whether it's a maximum or a minimum. Let's go ahead and sketch this now. I'm going to sketch it, two things. I'm going to sketch one with a +4 at the front. So we've got y is equal to 4, x minus 1 all squared. We're going to do this in our calculator, plus 16. Now, what you should see there is we've got a turning point at 116, but can't see it because we're not zoomed in, we're not zoomed out enough. Let's zoom out. There you go. Okay, you can see there that for this, let's zoom in a little bit and we'll zoom in and we'll sort of focus around here. Okay, can you see there it sort of turns? Probably got to zoom out one more time, just so you can see. There you go. There's our parabola. Now I'm going to get my little mouse. I'm going to move that across here. And I'm going to go to Windows and we're going to analyze the graph, and we're looking at this time, because this one's a happy quadratic parabola. We're going to analyze graph, and this has got a minimum. Pick a point to the left, pick a point to the right. As you can see there, we've got a turning point at 116. That is for the graph of 4x minus 1 all squared plus 16. Well, what about if I press tab and all I do this time is I make that a -4. So everything else stays the same. Everything else stays the same. X minus 1 squared plus 16. Okay, so when I sketch that, you can see that all this negative does, providing everything else is the same, the values of H and K are the same, is the negative does an inversion of that. So you can see there that this red graph is -4x minus 1 all squared plus 16. Again, turning point at 1 and 16. 1 and 16, there it is there. Okay, both share the same turning point, but of course it's inverted. Now, if I go back to my screen, there you go. That's our turning point. Now it says determine the y-intercept. Now, in the past, when you had a quadratic in this form here, y equals ax squared plus bx plus c. Or if I was to use just normal numbers, like if I was just to go to x squared plus 7x plus 12, well, the y-intercept is when x equals 0. But if x equals 0, then that's 0 squared plus 7 times 0. Clearly there's 0. And then it's just this plus 12. It's just this constant, which is the c part, constant. Now, it doesn't work for this. So obviously this would do, the y-intercept would be 12. It doesn't work because in this case we're looking at, it's already in turning point form. So notice in turning point form, yes, the same still applies. The y-intercept is when x equals 0. But can you see there that when I sub in x equals 0, minus 4, x minus 1 all squared, that's our formula. If I make that 0, well, what we've got is we've got negative 1 squared is 1. 1 times negative 4 is negative 4. Negative 4 plus 16 clearly is not 0. In fact, 16 take 4 is 12. Okay, now that's going to be, so our y-intercept for this is 12, which means it's not easy. When it's in this form here, the y-intercept's easy. It's simply just going to be that, c, our constant. Well, it's not our constant. It's clearly our constant over here, 16. It's not 16. We need to sub in x equals 0. So we've determined that the y-intercept is 12 for this. Determine the x-intercepts. Well, before we've been used to factorising. We don't factorise in this case. Let's do, again, we've got y is equal to negative 4, x minus 1 squared plus 16. Well, for the x-intercepts, again, y is equal to 0. But this time, we've got this. 0 is equal to that. Now let's go ahead and solve this. I want to solve this for x. So I want to get, if you like, this is where it gets a bit tricky, is that we want to get x by itself. So in other words, I've got this. I want to get this x by itself. Currently it's squared, it's multiplied by negative 4, and we're adding 16. So what we're going to do is everything that's furthest away, let's subtract 16 from both sides. If I subtract 16, I've got negative 16 is equal to negative 4, x minus 1 all squared. Well, you might notice there's a negative 4 at the front. So what do we have to do? We need to divide by negative 4, both sides. Now, if I do that, we've got negative 16 divided by negative 4. The right-hand side, technically, we've got negative 4 and negative 4. But the whole point of that is we're doing the inverse operation to cancel it out. We're left with x minus 1 all squared. Well, 16 divided by 4 is 4. Negative divided by negative is a positive. So that's going to be 4 x minus 1 all squared. Now, we look at this, and a lot of you will sort of say, oh, let's do the square root of both sides. That's good. But you remember that there's two solutions. There's two solutions when you do that. Why? Because if I was to ask you what is the square root of 4, you might say it's 2. Well, yes, that's true. But if I'm looking at a quadratic, then would you also agree that negative 2 times negative 2 is also equal to 4? So 2 2's are 4, and so is negative 2 times negative 2. So there's actually two solutions. There's two solutions to the square root of 4. And that is, so what we're going to do is we're going to take the positive and the negative of both sides. So really what we're doing is doing the square root of the left, the square root of the right. The square root sort of effectively cancels out that squared. And we've got x minus 1. Okay, but what you've got is the plus and minus the square root of 4, which is 2. And now, of course, well, we've got an x. We're almost there. Let's add 1 to both sides. And I'm going to put the x on the left-hand side. We've got x is equal to 1 plus or minus 2. Now, of course, we don't need to leave it like that because there's two solutions. 1 plus 2 is 3. 1 minus 2 is minus 1. So we've got minus 1 and 3 are our two x-intercepts. Now, of course, it says here, if any. Well, if you hit a roadblock, for example, if you're trying to do the square root of a negative number, you cannot do that. The answer to that is there's no solution. So if you're trying to do the square root of a negative number, let's just say over here, if this was -4, there's going to be no solutions. Okay, well, you think about it. If you put that in a calculator, your calculator's not going to be able to find it either. It'll have come up with some error. But anyway, this works, and there's my solutions. So we use this form, and we do things slightly differently. But again, really important to note that the y-intercept is when x equals 0. That applies for any graph. Okay, and if you need to reapply that, an x-intercept let y equals 0, but of course we're not factorizing this time. It's in this turning point form, so we're going to be doing it this way. We're going to be solving doing it this way. Okay, I'm going to leave this up here. Can I get you to pause this now and have a go at this? I'm going to reveal my answers shortly. All right, so let's have a look at this, and hopefully you have tried it at home. So we're looking at sketching this graph. So let's have a look at the important things. Well, if it's in turning point form, we have got y is equal to a, which is some dilation factor, sort of turns it x minus h squared plus 18, or plus k. So if I look at that, then hopefully we can see that here a is minus 2, h, it says x minus h. It's important. It says x minus h. If we've got x minus 1, that's going to be x plus 1, isn't it? So h actually, x minus h is -1. We'll talk about more of that in a second. And I'll give you another way of sort of recognizing that. And k is this 18, this constant here. So by looking at that, hopefully you can see that h is equal to -1, k is equal to 18. If we can identify those, then that means we've got a turning point at hk, which is -1 and positive 18. And if we have a look, if it is a sad parabola, because it's a negative, has a negative out the front, then that point there, the turning point, is what we call a maximum. Okay, now another way of recognizing what this h and k is if we ask ourselves, and I'll do it in red pen here, let's have a look. What does x have to be? What value of x makes this add to 0, makes this 0? So if you think about it, what value of x plus 1 makes that 0? Well, clearly x would have to be -1. And look, over here, -1, that's our value over here for h. Okay, that's always going to work as well. So as you can see there, that is got a turning point of -1, 18, and we've got a maximum. Determine the y-intercept. Y-intercept, we let x equal 0, and we solve. So we've got y is equal to -2 times 0 plus 1 plus 18, which is -2 times 1 squared is just 1 plus 18. 18 take 2 is 16. So a y-intercept is 16. We're going to sketch this in a CAS in a second to have a look and confirm. Determine the x-intercepts. X-intercept, let y equal 0, and solve for x. So I want to solve this guy here. Well, I want to get x by itself. But before we do that, let's subtract 18. And then I have this. And now, oh, we've got a -2 there. Sorry, forgot to bring that over. Now let's divide by the -2. That -18 divided by -2, of course, on the right-hand side. We should hopefully know that, I'll write it anyway, but we're trying to cancel that out. So there you go, they cancel. And that's going to be, I'm going to write it on the left-hand side. X plus 1 all squared is going to be 18 divided by 2 is 9. So is -18 divided by -2. That's 9. Now, I've got a squared here. I want to do the opposite of a square to cancel this out and simplify, which is the square root. So we're going to do that to the both sides. When I do that, it's going to be x plus 1. That's fine. But on the right-hand side, we've got to consider there's two solutions. We've got -3 times -3 is 9, and 3 times 3 is also 9. There you go. Now, we're almost there, but of course we need to subtract 1 from both sides. X plus 1, we want to subtract 1 from both sides. And of course, let's simplify. We've got gives us x is equal to -1 plus or minus 3, which we wouldn't leave it like that because we can get an exact value. -1 minus 3 is -4, and -1 plus 3 is 2, and there's my two solutions. Now, with that in mind, if I have a look over here, let's keep in mind we've found the turning point, which is a maximum at -1 and 18. We've got a y-intercept at 16, and we've got two x-intercepts at 2 and -4. And if I was to go ahead and to sketch those now, let's go ahead and sketch those. So we are sketching this graph here. Let's go to my calculator screen. That's not my calculator screen. Let's go here and let's go to a new graph. And we are looking at y is equal to minus. Let's put a minus in, and let's put 2. X plus 1 squared. So we're doing this in turning point form. And then we've got plus 18. Plus 18. Boom. Now, can you see there that it's sort of zoomed in a bit? I'm going to go analyze graph. I'm going to go to Windows Zoom. I'm going to zoom out. I'm going to zoom out, as you can see, there it is. Now, if I have a look, let's go to menu and analyze graph, and then we'll look at this is a maximum. See what a maximum is? It's the right there, it's sort of right up there is a maximum, isn't it? It's the highest point. Pick a point to the left, pick a point to the right. There you go. Our turning point is at -1, 18. And also, hopefully, you can see if I go to menu, analyze graph, 0. Pick there's one x-intercept at -4. That's being a bit annoying. And let's do it again. Analyze graph, 0. Boom. There you go. And look, just trust me. If I was to count up this value up here is also 16. 7, was it 16? Yeah, 16. Okay, so there you go. That is everything looks right to me, and we have now done that. So hopefully you're feeling okay with that. Now look, got to practice this a fair bit for sure. Now, we've looked at this sort of thing in turning point form, but how do we get things in turning point form? Well, we're going to have to do that by completing the square. So this is a fair bit in this. First of all, let me just talk about these ones here where we're completing the square. Okay, so notice that these are in what form we're looking at, which is, these are in standard form. What I mean by standard form is y, I don't want that. Let's try that. Y is equal to ax squared plus bx plus c. Well, if a is 1, then we can complete the square. Okay, we can complete the square. And of course, we are assuming, generally speaking, when we ask you to complete the square, a lot of the time, a lot of these ones can't be factorized. So we always just think about, remember, we always try to factorize first. Okay, but generally speaking, a lot of the time we might, if we ask you to complete the square, it's generally because it can't be factorized. Okay, so let's have a look at these. This one here, we're looking at x squared plus 6x plus 15. Now, we have looked at completing the square, but not in the context of sketching parabolas. What are we doing? Now, first of all, I'm going to just get you to have a bit of a think about what are we doing when we complete the square here? What's the process? What are we thinking about?